Okay, new. There we go. Okay, so we are just starting over here. Okay, so you have a new Arduino. Okay, a new code. Okay, so what is this going to do? The minute we hit start, it should blink the L here. So this is the by default code that comes when you start a new, right? So it works. Okay, so we see the LED is blinking. Okay, you see that here, right? Okay, so our LED is blinking. Okay, so let's look at our code. Why is it doing that? What's the basics, basically? Okay, so these are the things you need to know. Okay, right? So we need 2 blocks, right? I've already said it, right? So you need void setup and bracket this way. You need a void loop with bracket this way. What's important about this structure, it's notice these are functions, okay? So this is what functions look like. So say it's called function, and then it's got bracket, okay? Do you notice that? Do you see that? Okay, this is just the way they're built, okay? And a bit like the if and the while and the next ones we'll learn about, they need opening curly and then closing curly. And then inside of here is what you'll put, right? So stuff will go here. Okay, so this is the basic structure. Can you guys 30 seconds go on your own screen and literally just retype this? Okay, this is the basic shape of functions. Can you guys do that, please? And then can someone share their screen if you don't mind? Okay, so that's not being recorded, okay, because now it's on a different page. Oh, but I won't be able to see it because I'm sharing, right? Right, okay, so let's actually just skip that. Let's go faster. Let's keep going. Okay, can you guys give me a thumbs up when you got that up? Okay, easy enough? Okay, so stamp that in your memory, guys. This is what functions look like. Okay, you see that? So bracket, notice this is curly. It's totally different. Okay. All right. Okay. So let's erase this because we don't, well, maybe I'll leave it. I'll just comment it. Okay. Very important other thing to comment, right? That's a very important feature. So you do /* or at the end */ to end the comment. That's the first way. The other way is just to put /. Okay, so I know I'm repeating, but it's by repetition, right, that you learn. Okay, all right. This here, why are we using this here? Okay, so this is a function. Do you see that? Right, you see the shape of it, right? So some word and then bracket. Do you see that? So it's got the shape function and then bracket. Okay, so where you can play is what's inside, right? So I'll put X. So this is where you can play. It's on the inside part of that bracket. All right, so I'll just put comments here. Right, now this function in this, now some of you are going like, hold on, you just said function needs the curly bracket at the start and at the end here. Well, it depends on the function, if that makes sense. Okay, so if it's something like as you work, you'll see the difference. Okay, so these are more like it's more like a single command, right? And these are more like that. This is not a single command, right? Because you can put gazillion of commands inside, right? So for now, don't get too stressed about why sometimes and why sometimes not. Okay, that will get to you with time. Okay. Each of those functions, right, that are more like commands, like this one here, each of them has different methods, right? Like the way you write inside that bracket here, the 13 output here, that varies. Okay, and this is where you need to constantly check in a reference, okay? So I don't memorize everything, okay? So here's an example of a very simple one. You see here, delay, right? This one just takes one element inside the brackets. You don't need to put more. Good to go, right? So some you just put one item, some you put two, right? But then when you'll do stuff like a for, and this is why we needed 3 items. So you had X, semicolon, I'll just put variables here just to fill it in with something, right? And then Z, right? And here, so in the case of the for, you're separating them by semicolon. In the case of a pin mode, it's just that's a comma, right? Right? And so again, that's called syntax. Okay, so how do you know the syntax? Again, if you do it more, you just memorize it, basically. So some of the syntax now I'm starting to memorize myself. I don't do that every day, right? C for Arduinos, right? And so even myself, I need to go check, okay? Okay, comments up to here. Are we, can I just check quick the chat? Can I get a couple of thumbs up? Something to repeat? Okay. So, does that make sense here that there's many kinds of those animals, okay? So this is kind of what I'm trying to make you guys see. It's maybe, I guess, that's one of the advantages of the more recent languages. I don't have enough experience with, say, Python and Java. I'm actually not very interested in those, especially Java. The one thing I'm more interested in if I learn a new language would be the really recent ones. So the one especially I would be interested in is Rust, and there's a bunch of other ones. Anyway, they're out there. Okay, so to code like Apple apps, right? Like apps to go on iPhones. I keep forgetting those names here, but it's okay. And then for Google, same thing, right? To program apps straight on Android, there's languages that are very efficient, and I think that's where those start shining. Is that they're even easier than using C. But believe me, you won't find. I'm serious. You won't find anyone saying to you that learning C is a waste of time, which is what we're learning. No one's going to tell you that. Unless your goal is just to get something very quickly done in, say, one language. Fair enough, right? But the structures, this is very important to preface with this. Whatever you learn in C gets applicable. The principles don't change. When you make an if, the structure, the logic behind an if is the same. The structure behind a for is the same, so on. And while loops and so on, okay? So that's very important to understand that. So whatever you're learning right now is applicable to other languages. It's just you need to change the... Can someone complete my sentence? The only thing that will change will be the... Starts with S. The syntax. Good. Does that make sense?
So guys, one more thing. You can consider C as the foundation of programming.
Yep.
So once you understand C, it'll be very easy to understand other languages.
Yeah. Yeah. And it's still around, as I said, like Windows, for example. Again, don't quote me because I don't know the numbers, simply because I don't have experience programming in, the Windows environment itself, right? But my understanding is half. It's probably changing as the time goes, but something like half of Windows, like the whole OS is built on C++, basically, or C#, okay? And so some derivatives of it, right? So you can be sure you're not wasting your time, okay? So I just think that's important to say. All right.
How does that C code turn into like a display though for like the actual Windows operating system?
Well, that's where it gets complicated, man.
So it's the same thing as what you guys are seeing here. So let's say number 13, you can turn that into a button, and then you can say over here what you want that button to do on the right side. So you know how you have your start button? So when you click on your start button, there's a code that tells that start button what to bring up and where to bring it up from.
Yeah, the difference here, right, is when you're coding in something huge like an operating system, right? Like, okay, guys, can you realize the amount of work? Like, it's easy to say, you know, to kind of be upset at Bill Gates, for example, for being rich like that, right? He's insanely rich, and there's no sign of getting off, right? Because he's just in this virtuous cycle, right? Just gets richer, richer, richer. Fair enough, we can disagree with that. My point is, do you realize the work, the tremendous amount of work that went in building something like Windows and Word, like the program Word? So essentially, your question, Arman, is very complex because it's basically built layers upon layers upon layers, right? So picture it as having like, listen, I don't code in for Windows, right? But how I picture it is that there's basically a set of layers, and so you call for graphics, right? So you'll call from the library some. You'll literally call, give me a box, right? Like an invite, right? And then you can call to have like an OK button, right? Like when I did a bit of Visual Basic back then, and this is how it worked basically, right? So you called literally graphic items, and then you connect those items to call, you know, to react when you push the button. But then this is what you do on the user side. But then when you are behind those things, you're like, this is where Microsoft, as an example, like, it's ridiculous the amount of work that went into building something like that. It's just ridiculous. We cannot measure it. It's difficult to imagine. And like Monsieur Betty and I, like, we've seen the earlier versions of Windows, like Windows 3.1, for example, right? I grew up on that, right? And it was still amazing it was absolutely amazing for back then, this thing. But anyway, so that's where it gets complicated, right? Like, coding, guys, this is why, like, people, well, first of all, this is why Microsoft has how many coding engineers, right? And this is why when you build a software company, this is why you need gazillion people. Facebook, Apple, like, how many people each of those companies hire? It's freaking complex. I think that's the answer, Armin, basically. It's layers upon layers, and then some companies have built systems where a user like me, Monsieur Betty, or yourself, you guys, you can just take those softwares that are built for you, and then, like Visual Basic, that's the one example I know, but C# can do that for you, and so on, and Java, and all of those. And then you call boxes, you create windows, but you're not creating anything. It's the programmers at Microsoft that built it for you to call the function to make a window that will then, you'll plunk a button on it. All you do is literally like play, you just play art almost, right? You say, oh, I want it here, and then you just connect dots. You say, this button, when I push on it, I want this to happen and not that. And that's where it gets really intense, right? Like, especially when you get databases involved. Does that make sense, Armin?
Yeah, that makes sense.
So, guys, we owe a lot to those companies. We do. Like, it's not that I'm a fan of Microsoft. I'm not a fan of that. I'm just, as a user, like, if you were to open the hood of those machines, like, really open it. Like, I mean, like, to see what happens inside of just Windows 10 booting. Are you out of your mind? This is unbelievable. The levels of complexity happening when you start your phone, it's just unreal. And then we complain that it takes 2 seconds too long, right? And It's ridiculous, the complexity. Absolutely ridiculous. Like for someone, a single person, to build all of Windows 10 on their own, let's make a guess at the amount of thousands of years. I'm not joking. It's gotta be thousands of years on a single person to build something like Windows. Monsieur Betsy, do you think I'm exaggerating?
I know it's probably more than 1,000 years if one person's doing it. It's a lifetime commitment. Maybe more.
Oh, it would be, yeah, it would be hundreds of, I mean, it's hard to number, but it's gotta be really high. Armin, does that make sense? And the rest of you guys, does that make sense? The complexity involved is, you cannot even start to feel it. It's so high that the only thing you can do almost, I'm using a silly image here, but really the only thing you can do before it is bow. Like, I'm not even joking. Like,
yeah, it's millions of lines of code.
Oh yeah.
Millions.
Oh yeah. It's millions upon millions, okay? And so your question is huge, basically, Armin, right? Because the answer to that is what we just said, essentially. It's super intense. Good to go?
Yep.
Okay, that was good. Okay, other comments, guys? You just interject, okay? This is nice. I like that. Okay, are you guys able to change this code quick to make it blink faster? Can you talk to me? So how are we going to do that? Can we make this blink faster? Okay, I need you guys to talk to me. Yes, to reduce the delay, exactly. So how are we going to do that?
By tuning the delay between the brackets and the wait time.
Perfect. So give me an example. So if we wanted
500.
Right. So what's going to be the effect if we put that 500?
It's going to blink for, every 500 milliseconds.
Right. So it's going to be half as long, right, as what we had, right? So so 1,000 milliseconds is 1 second. So now it's half a second. So let's just try that, right? So let's hit start. Okay, Hassan, you need to mute your mic, please. Okay. So do you see the blinking? Now, remember yesterday I talked about the simulator time here. It's not real life. Okay, so you see the blinking. It's not very fast. So let's make it even faster. Let's go to 200. Right? Let's see if it's going to be visible. Right? So do you see that? It's trying to blink. Okay? This is...
Wait, sir?
Yep.
So what's after the bracket? We don't have to change that part?
The
two, that was called... The two lines?
You need to talk to me. Which part?
Like after you read the two slashes.
Those
don't you have to change the one side?
Okay, of course. But like, to me, sure. I mean, but this is just a comment, right?
Okay.
Right? Like, it's just okay. That's a very good point. Like, fair enough. In a proper code, you would need to change it. Yes. So, yes. Okay. Are you guys clear what the high does here and what the low does? So the high does what? Guys, we talked about it yesterday. So high equals what? And low equals what? Come on. Please talk to me. Equals. Okay, I can't see the chat, so if you're typing... Okay, Tyler, thank you. So that's what it is, okay? Guys, I'm hoping you guys are thinking as we're doing this. Okay, I hope you guys are not just munching and watching whatever you guys are watching. Okay, like I'm doing this for you guys. I'm not doing this for myself here. Okay. So high is a 1, What's the other way to say a 1? Please, come on. What's the other way to say a 1?
Would it be 5 volts?
Perfect. So a 5 volt in the case of this board, because it works on 5 volts. What's the other thing it could be as well?
True.
A true. Perfect. Okay, so if that's the case for high, what's the equivalent of 1 for low? You need to talk, guys.
False.
Hey?
0 or false.
So it's a 0. What's the equivalent of 5 volts?
0.
It's 0. Whoa. And the equivalent of true is obviously false.
Volts.
Okay, perfect. Thank you. Very nice. Okay. What's going to happen if we comment this part out? Just like that. So I deleted digital write 13 low and then delay 200. What's that going to do now? Well, how about we just hit start simulation? Are we any surprised that it stays on? Right? Because I'm not turning it off, right? Right? Because low is off, right? So that's why it's staying on. Okay. Okay. Okay, so I got an idea for you guys now. So this is where we're going to start to code, right? Like proper. Okay, so let's get rid of this. Okay. I want you guys to blink the LED on. Well, just because we want it to go fast here, right? Because we don't want to wait and watching it. So first, we'll put our delays kind of low, 300-ish. I'm going to ask you to blink the LED here. Instead, right now it's blinking forever, right? Okay. First challenge, blink that LED 3 times now, please. Okay, so I need you guys to talk with me. Okay, so talk to each other. So unmute yourself. How about I stop sharing? Okay, if I need to stop sharing, I'll stop. Okay, okay, talk to me. How are we going to get this light to blink just 3 times now?
You could put a for loop.
Exactly. So, do you mind sharing your screen? I'm not recording your names. I'm not recording your names, guys. Okay?
Yeah, 1 second. I keep fumbling the thing.
Yeah.
Is it sharing now?
Yeah. Okay. So can you walk through that?
So I think I remember what the for loops thing is. What else is? I just wanted to get a counter for 3 times. I keep forgetting how you would do that.
Very nice. Okay, very nice. Okay, so how about I pick up from here? Okay.
Okay.
Okay. Thank you so much. Okay. So that is the good idea. Okay. It's just like I just want us to be efficient here. Okay. That was very nice. Window. Circuit. Not the right one. I think so. Okay. So we need our 4. Right. So we'll type 4. Now remember, all functions are the same, right? So the minute it's not just a command, basically, right? Like a single line command. So now we'll need the curlies, right? So you go bracket, enter, curly, opening curly, and then closing curly. You guys have that, right? This is just our basic structure, right? Now, I like personally to always format my code because it's just neater. Okay, so hit tab, right? It makes your code much cleaner. Okay, so right here and there, we're going to go straight into the reference. Okay, so C reference Arduino. Okay, now that might not be the best one actually. So let's see how it looks on this one. Okay, so you see we got language reference. You guys should be able to see this. Let me just confirm I'm still recording correctly. I am. Okay. Okay, so this is, it looks very complex. It's really not, but let's go to the bottom. Which one am I looking for? 4, right? So it's a structure. It's part of structures, right? So you look for the 4. So it's a control structure, right? And look, it's right here. So right click on this guy, 4, and it will give us all the syntax that we need to know. Okay, so this is it here. So I personally like to copy paste the theory and then bring it in my code, if that makes sense. Okay, because I can look at it from my code. Okay, are we good to go with this? Right? Okay, so I'll just comment it out before I paste it in, right? Because I don't want this to be part of my code, right? Okay, so I need to initialize, and then I put semicolon, and then I put condition, and then my increment, and then inside will be whatever it's doing, and then that's it. So a for loop, is there a drawing? There's no drawing here. For control structure image. I'm trying to show you a, yes, something like this here. Okay, so this is more computer science here, but this is like, that's basically what they are, right? And that's why you guys in computer science, this is why you learn those things, right? So this is basically what a for is, right? So you initialize, you check if the condition is true. If it's true, you do it. You get into the body, basically. Oh, they put it as a while. Okay, that's not what I want. I want a for. What's this one? Okay, give me 1 second. 4C. Thanks. Okay, that's really frustrating. It is really a control. For loop and C. There we go, flowchart. There we go. Okay, this thing here. Okay, so any of those works here. There we go. Okay, so we initialize, right? And then we check for the condition of whatever. It can be absolutely whatever. If it's true, you do what's inside the loop. You update. You check again for the condition. And the minute it's false, you exit. Are we good to go? Are we good to go with this? Can I get some thumbs up? Are we good to go? Like, does that make sense, what I just showed? Okay. Armin, can I bug you? Mara, does that make sense, what we just talked about?
Ish, yeah.
Okay, and Kara, does that make sense?
Yeah, that makes sense.
Okay, anyone else? Arwen, are you with me here? Just bugging random people. Okay. Okay, so we need to initialize, right? And then, so yesterday, remember I taught you about local variables? So that's a very helpful trick, is essentially that variable that we'll use inside of that for loop will only exist within the for loop. It literally gets destroyed the minute the code gets out. When you build big applications, it's really helpful to do that. Okay, so you're going to go and say, now this is where a variable kick in here. So we need to declare a variable integer I, will go simple, we'll say is equal to 0, right? So this is my whole thing here. It's the initialization. Semicolon. What's my condition? So as long as it's under, so because I'm starting at 0, so as long as it's under 3, I'm going to do what's inside the loop, right? So as long as I is smaller, right? Because I don't want to do that same mistake that I did 2 days ago, right? So as long as it's, because it's got to be true. So the condition here has to return true for that code to run inside of the for body, okay? And then what do we do every time that we finish the loop, basically, right? So every time I finish, I need to do something, right? Because a for, this is what you do, right? You increase or you decrease, right? Your value. You can. So it's basically you check for the state on a counter, right? Like a value. So we'll do I++. So that's the way to increment on the fast, okay? On the quick, so you do I++. Are we good? Comments? Are we good? The comments, questions, something that you look at it and go like, woo, like that's too much or something. All right. So how about we run that and see what happens? Right? So it's 300. Let me just check. It should run 3 times and then stop. Oh, but we got a problem. Right. Right. Because we're inside of a loop. Right. Right. I just thought of that. Tyler, we're having a problem.
Would you just declare I outside of that for loop thing? So in between setup and void loop?
It won't make a difference. So right now the problem we got, okay, is that it's this loop. So right now we got a loop inside of a loop. Does that make sense? So what's going to happen is the minute it finishes the for loop here for 3 times, the minute it finishes it, it exits and starts over at the start. And then it's just going to redo it. So if we run this, it's not going to work. Right? If we run this, it's going to blink 3 times and it's starting over. 3 times, starting over. 3 times, right? So that's useless because that's not what we said. We said it's got to run 3 times and stop. It's got to blink 3 times and stop. So what are we doing? Well, do you remember yesterday there was that trick I did with the while to stall? Do you remember that? Right? So we could do that. That's a bit of a dirty trick here. Okay, so that will teach us how to use a while. That's it's a proper use of it. It's a bit forcing it. So how about we declare an integer here at the top, right? So as you were saying, Tyler, so let's declare our integer at the top here. So whatever, let's call it x. And let's say it's 0, okay? Right? We're not going to change x. And you know what we'll do? We'll just make it so that it's false all the time. So let's look at the structure for while, right? So that you guys see what I'm doing here. So it's right here. So I'll right click, open my while. Okay, so let's copy this. That's how I do it. If you don't like the way I'm doing it here, you know, copying, pasting it in my code, because we're learning here, right? So this is kind of the, okay, so this goes here. Right? When you'll be stronger at that stuff, you can stop doing that, basically, right? If that makes sense. Okay, so don't forget to comment it out. right? So that I'm done with. Okay, so the structure for a while is the same, right? So close bracket, bracket, and then curly, right? But inside our while, we'll leave it empty. So it won't do anything. Okay? Guys, I'm going to propose another way of doing this right after this. This is not a very... Like, it works, okay? But there's another way we could do it, okay? So I'm... Like, and that's the beauty of coding. You can often do the same thing 50 ways. Yeah, in this case, it's so simple. There's not 50 ways to do it. But, okay. So how about inside of the while, right? The condition testing, right? Oh, someone... I heard bling.
Yeah, Mr. Broder, is it okay if the people from the other group just quickly like leave this meet and make another meet so we can discuss what we're gonna do? Because it's very hard to do it on Google Docs.
Yeah, of course.
All right.
Yeah.
Thank you.
So hold on. So can you guys share somehow your like what you've done today, like very quickly, just like a quick paragraph? Share with me. It's okay if you use. Like, that's why that Google Doc, you kind of need it, okay? Because I need something to keep track.
All right.
Okay? Just keep it simple, but you guys can meet on something else, of course.
All right.
Okay, so make sure you share with me, though. All right?
Of course.
Okay, thank you. Okay, sorry. Right, so here, how about we say if x is greater... greater than 0. So, folks, can you talk to me? Is that true? Since I declared it to be 0, is that true here? This condition here? Can you guys talk on the chat? Is that going to answer? Is that going to give true or false?
I think it's true.
It's true. So, hold on. I'm declaring x to be 0 at the beginning of my code. Right? And then here, I'm checking if it's greater than 0. But I'm not changing x anywhere, right? I'm not doing anything to x. So what's the result of this here? If I'm asking the computer, the Arduino, to check is x greater than 0? If it's 0, what's the answer?
Equal.
I can't hear.
It should be equal.
Okay, okay, hold on. I think I'm not being understood. Okay. Is 0 greater than 0?
I mean, they're the same.
So, we get that, but my point is, what? Okay, guys, I'm trying to make you guys see how that machine thinks. Like, it's not about how we think about it. It's about how the machine thinks about it. What will the machines think if we ask it if x is 0 at that point, and I ask the machine, is x greater than 0? What's the answer the machine is telling me?
False.
It'll be false. Does that make sense? That was the answer I was looking for, folks. Are we getting this? I'm literally making the computer, that machine, ask itself, is x greater than 0? It's telling me false. Oh, sorry, I want it to be true, actually. Oh, crap. I want it to be true. Right, because I want it to stall inside of that bracket. Right, so I want it to be true. My apologies. So it's the opposite. I needed to do the opposite. So is x equal to 0? So it's still okay that we did what we just did, because we need to be very good at doing these kinds of comparisons. So if I had written x equal, is x greater than 0? The answer to that is, talk to me. Talk to me, guys.
False.
False. And then, if I have the opposite, is x smaller than 0. What's the answer to that? Someone else, please.
False.
It's still false, right? Now, it's good that we talk about the equal here. This is common kind of mistakes. Even myself, if I go too quick, I'll forget it. Here we're saying equal to mean to assign the value 0 to that x here. You see that? But here this equal doesn't do that at all. Here what it does is it's comparing. So it's asking the computer, is x equal to 0? So this is syntax. So you need to give it equal in this case. So very important. So we'll put a comment to this. So essentially, because x will be equal to 0, it's going to get stuck in the loop here. Okay, so now it's going to blink 3 times and stop. It should. So let's check it out. See that? So now it's done. Because it's literally getting sucked into this loop here. Okay, comments, questions? Okay, so I'm back on the chat here, so I'll stop the video here.